Okay, our last video showed the difference between all of the chapter 6 and 7, 1 and 2 stuff so far. What I want to focus on is, in the last section, we did finding probability in a sample with means. So using the central limit theorem. So today we're going to use the central limit theorem for finding the proportion, the probability with a proportion instead of with a mean. This video is just going to show you the formulas, and then I'll post some examples separately. First of all, let's talk through proportion again. Okay. Remember that it is just a fraction or percentage. Remember that it is P. P is the proportion. So, for example, 1 out of 6 Americans have blue eyes. This is on the rise, by the way. And so 1 out of 6, or 17%, or 0.17, all of those could be used for P. Now, when we're doing computation, it needs to be a fraction or a decimal. Don't compute with percentages. I have a new letter for you. This one is P hat. See the little caret on top of the P? P hat is the, I'm sorry, I am looking for my pencil. It is missing. P hat is the proportion for the sample. So now we have sample and we have population. This one is for the sample. So we call it P hat. It's just got a little hat on top. Okay, so that's for the sample. Formula-wise, well, it's kind of funny little formula. If we want to find the population proportion, we take the number of success, I guess if we want to call it that, and big N always meant the population size. Okay, for P hat, since that's for the sample, again, it's the number of success, and this is the sample size. Okay, so that's your fancy formula for proportion. It is not our fancy formula for the day, however. Okay, so in a binomial distribution, if you'll recall, probability of success is P. We also needed, in order to use the CLT, NP and NQ both had to be greater than or equal to 5, which meant that I needed my sample size to be at least 30, so that would make that happen a little bit better. And if the probability is great enough, then it will turn into a normal distribution. This is from showing you that demonstration from the tool online that shows how it took all of the little samples out of the population, and then it took, instead of the means, it's going to look at the proportions. And when we take the sample means, it turns into the same as the proportion. So I have mu sub P hat. Yep, there's a little hat on that P. Mu sub P hat is going to be the same as the population proportion. So the mean of the sample proportions is the same as the population proportion. And so that only happens if I have the right sample size and if I have NP and NQ both greater than or equal to 5. Okay? So mu sub P hat is the same as the proportion. Sigma sub P hat comes from the same idea as before. Remember, sigma sub x bar was the square root of NPQ? Sigma was in square root of NPQ, and when we did x bar, we needed to take this guy, and we're dividing it by n, just like it was in the sample means. Oh, I'm off the screen. Here we go. In the sample means, the sigma sub x bar was sigma over square root of n. We're going to do that same thing here. What's going to happen is, To simplify this, this is the same thing as all of these to the 1/2 power. Remember, square root is 1/2 power. And then this is going to simplify so that I get p to the 1/2 q to the 1/2 over n to the 1/2. Well, 1/2 power means square root. Okay, so this isn't a mystery. This is just coming from that same idea of I've got to divide by the n. So we're going to take this as our new sigma for proportion. This is the fourth sample, and let me grab our formula sheet so I can show you that it is on here. You're under chapter 7, population proportion, sample proportion. Those are the little formulas I just showed you. This was our sample means, okay, for z. Now I'm saying mu is going to be the population proportion, and sigma is going to be the square root of pq over n. Square root of pq over n. That's kind of ugly. If you want to rewrite it, you could. Okay, so our new mean and standard deviation for when we are finding the probability of a binomial distribution with a proportion, not a mean. All right, so let me just show you this with, let me show you our new z-score. Hello. All right, for the z-score, normally for individual values, we just find x minus mu over sigma. But when it's a sample proportion, x goes to p hat. P is mu, that's what we just wrote down a second ago. Mu sub p hat is p, okay? And then sigma became the square root of pq over n. So we're just replacing these with our new proportion language and our formulas that come from the central limit theorem. Okay, so this is all because the central limit theorem tells us that it's going to become normalized when we take those little samples out of the population and we find the proportion of blue-eyed people, for instance. That when we do that in the sample, then we can find the z value using these things, because the mean is going to become the same as the proportion, and the sigma is going to become the square root of pq over n. Alright, so we're going to put some numbers in there, and then on the next video I'll show it to you with some words, okay? For this one, we're going to use the CLT to calculate the sample proportion and standard score of the sample proportion. Given that P, which is the proportion for the population, is 0.54, X is 563, and N is 1,000. What it doesn't give you is our handy-dandy p hat. So for p hat, we had the formula x over n. So x is 563 over 1,000 for n, and there's p hat. Okay. To find mu, well, by golly, we just wrote down that mu is going to be the same as the proportion. Yay! And sigma is going to be the square root of p, which is 0.54, q, which is 0.46, over n. Okay, well, let's go find out what that is. Point 0.016. 3 decimal places, huh? Since this one's 2, everything rounded to 3 would be happy. Okay, we need a z. Oh wait, it just said the sample proportion and standard. Oh yeah, standard score. Okay, read the question. So, our new formula for z that we just wrote down was p hat minus p over square root of PQ over N. P hat is our sample proportion. P is our population proportion. Our new standard deviation. When you're doing this on HOCS, we'll have to see if that's sufficient, or if you might need to use it in exact form. We'll see. 1.44 is the z value that we're getting. Oh, and that's it. It didn't have a question associated with it. Just find the z. And there you go. So now we could go and find a probability of being more than or less than this proportion in the sample. Okay. All right, next video is going to show you how we're going to put that together with words.